Hi, welcome to CS Glitz. In the last video, we learned about string, indexes, slicing, and string methods. In this video, we'll focus on lists and references. First, we'll cover the basics of list. And then we'll move on to advanced methods and topics. A list in Python is an ordered sequence of objects, just as the string is an ordered sequence of characters. We can declare them by using square braces. Elements are separated by comma. Now, A is a list type variable that contains 3 integers. We can use built-in function len to get the number of elements in a list. Lists in Python are heterogeneous, which means that they can hold any type of data: string, float, or even other lists. Notice that length of the list is now 6 instead of 7 because it's treating the list as a single element. Let's try something in Python shell. To access an element, we can use indexes like we do in string. We can use type function to get the type of individual elements. To access the element of the last element list, we can again provide the index for the nested list. As lists are mutable, we can change individual elements by using index. Using a list, we can easily hold many values without defining different variables. Similar to strings, we can iterate through the list using for loop. Let's write a program to display marks of different subjects in a table. We are printing the subject right aligned. We can also iterate the list using index. Now, let's try to make a horizontal bar chart represented by x. The number of x will depend upon the marks obtained. We are limiting the maximum number of x's to 40, assuming that marks are out of 100. Don't you think bar chart looks more like a X chart? So let's make a proper bar chart. We already discussed in the second tutorial, remember? We can use Unicode characters. Let's display obtained marks as well alongside the bar. Thinking through more cases like these and coding them is really where the main learning happens. Much more than learning to some dude on YouTube and copy pasting examples from the internet. Let's try to assign a list to another variable. Now let's see what happens when we try to change the value. Both have been modified. This is happening because both variables are object references. All variables in Python are object references. The objects are stored in the memory and contains associated values and methods, while references just store the addresses of the object, not the values. In Python, variables are actually references pointing to the object. Let's understand this through some examples. Consider memory as a table where we put values. When Python executes a equals by, it will first create a string by in the memory, then creates a variable a that points to this str object. Think of the objects as luggage and variables as a luggage tag. When we need to find the value of a, then it will go through the associated object. When Python executes b equals a, it will also point to the same object. If we modify b, then it will actually try to modify the string object. Since strings in Python are immutable, we cannot modify them. So instead, Python will create a new string object, byte, and make b point to the new object. Again, when Python executes a equals b, it will also point to the same object. Right now, there is no tag for the first object, so there is no way to use it in our program. As a result, Python will destroy the object, freeing up the memory. Now, let's take the example of lists. After executing b equals a, it will also point to the same object. Unlike string, lists are mutable. So, when we try to modify b, it will modify the object. Since they both share the object, a will also be modified. Back to our program. This is the reason when we change new colors, the element of color is automatically changed. We can check whether two variables are pointing to the same object or not by using the id function. It returns an integer which is guaranteed to be unique and constant for the object during its lifetime. As both are having the same IDs, they are pointing to the same object. If we create a new list with the same content, it will be stored in a different location. We can check whether two variables are pointing to the same object or not by comparing their IDs, or we can compare them using the identity operator. If two variables are pointing to the same object, then it will return true, otherwise false. Similar to is, we can also use is not. We don't need to create the copy manually. We can just use the copy function. Slicing also generates copies. We are already familiar with slicing from the last video. List constructor is a method that takes an iterable object and generates a list from it. We can use it with strings as well as any other iterable. This is an elegant way to generate a list for all the odd numbers less than 10. After declaring a list, we can insert new items at the end by using append method. As we can see, they preserve the sequence of data. Now, let's modify our marks chart program to take the values from the user instead of hard coding it. This is how we can create an empty list. Back to methods, append will always put the elements at back. But if we want to insert in any other place, then we can use the insert method. It will insert the element at index 1. If we give out of range index, then it will just insert at the end of the valid range. To insert multiple elements, we can use extend method. It will extend the list by appending all the items from the iterable. We can use any other iterable as well. Remove method will remove the first item from the list whose value is equal to 5. It raises a value error if there are no such item. Pop method will remove and return the last element from the list. If we specify index, then it will remove and return that item instead. It raises a value error if we give an invalid index. We can remove multiple items at once using the del keyword. To remove all the items from the list, we can use clear method. This is equivalent to we can also delete the whole variable using del. As we can see, A does not exist after deleting. Or we can delete a single element. Let's talk about two arithmetic operators that work on list. We can concatenate two lists using the plus operator. Let's try to print ID as well. As we can see, it creates a new list and then A will point to that instead of appending. We can also concatenate the other side. It's the same as this. As before and after IDs are the same, we know that if we use plus equal, then it will just append item in the same list instead of creating a new one. Similar to strings, a repeat operator on lists will just repeat its content. We can use the shortcut operator with repeat as well. We can use it with plus as well. As we can see, it always repeats the inner element. We can use this to create a zero matrix of size 4 by 5. Let's try to write a program that will remove all the even numbers from the list. The only problem with this approach is that it will again search for X to remove it from the list. Let's try it for 50,000. Printing big list will take up all the space in our terminal, so we'll just print the first 10 elements. We know that it's taking some time, but how much? Let's find out. We can use the time function from the module time. This will print the number of seconds passed since 1st January of 1970, known as epoch. As it's returning float, we can save it in a variable, and then we can again call it after our operations. Then we can just subtract it to get the duration in seconds. As we can see, it is taking a lot of time for big lists. Let's try to do it using pop method. We will go through all of the indexes and then check for even numbers. To understand why we got an index out of range error, let's take a simple example of a list of 4 values: 1, 2, 3 and 4. First, I will be 0 and the element at 0th index is odd. Then it will check for index 1 value, which is even. So pop will remove it and rearrange the list. Then I will be 2 and element is even. Pop will remove it too. Next, it will check for the value at index 3. List shrink due to rearrangements. We can avoid this problem by removing elements from right to left instead of left to right. First, we will check the rightmost element. 4 is even, so it will be removed. Then element at index 2 is odd, so it won't be removed. Again, element at index 1 is even, so it will be removed. And finally, element at index 0 is odd, so it won't be removed. And this will be our final list. Let's fix our code by starting from the last index and going till the 0th index. As we can see, this is way faster than remove method. Now, instead of modifying A, let's try to copy every odd element to another array. And then just change A to B. This is even faster than the previous one. The only drawback is that we are using an extra memory. So it's a trade-off between speed and memory. Which one should we use? The answer depends upon how big can the input be? Thousands, millions, or billions? Is speed more important, like supercomputer crunching numbers, or memory is scarce, like smartwatches or tiny IoT devices? There can be some other factors too. Coders often face these type of choices, and the answer will be different in different circumstances. Let's explore some more list methods. We can use count method to get the number of occurrences of a value in a list. To search for a value and get its index, we can use the index method. Similar to the index method, in a string, we can also provide a start or a start and an end. If it does not find the element in the specified range, then it will throw an error. We can use membership operators to check whether a value is present or not. We can reverse a list using the reverse method. We can use slicing as well. Remember, slicing does not modify the list. Instead, it will return a copy. So, we need to reassign it. To sort a list, we can use the sort method. To sort in decreasing order, we can specify the reverse parameter. We can also give a function by specifying the key. It will then sort based on the result of the function on each element instead of the actual values. As we already know, abs function will return the absolute value. So, numbers are sorted regardless of the sign. We will learn about how to create our own function in the later videos. We can also sort the list even if all the elements are lists. Here, the sort method is comparing different lists. We can use all the comparison operators on lists. It will compare the elements one by one. If both elements are the same, then it will compare the next one and so on. Just like a dictionary order. Now, it is sorting lists based on the result of length function. Instead of actual values, they are sorted in the increasing order of length. Sometimes we want to assign values from a list to multiple variables, which is called unpacking of a list. For unpacking, we need to have the same number of variables as the items in the list, neither less nor more. However, in the case of more values, we can pack the remaining values in a single variable. We can pack using the asterisk operator before the variable. This will generate the list for the remaining items. We can use it on any variable. However, we cannot use it more than once. It can have a single element or no element at all. We can unpack a string as well. But remember, it will always returns a list, not a string. We can unpack any other iterable object as well. Even though we can use it with a single variable, we should always use a simpler notation. If we use an asterisk without assignment, then instead of packing, it will unpack the list. What this will do is put each element separated by a comma without the list, which is same as passing values individually. We can use unpack to pass arguments in any function. This will create a range object with parameters 1, 10, and 2. We can unpack to create a new list as well. We can unpack strings. Or any other iterable. Let's display a list of fruits. Sometimes we want the index information as well. If we display the item number, then we have to change the loop to run on indexes. Now we lose the good structure. If we want to iterate on some objects alongside a counter, we can use the enumerate function. This will return two items, an integer and value. The value will be taken from the iterable and counter will increase by 1 in each iteration. We can change it to start the number from 1 instead of 0, so we don't need to add 1. Another useful function is zip. When we want to traverse two or more lists, then we can use it to get items from them. Let's say we want to buy 1 apple, 3 bananas and 2 oranges. This will get items one by one from both of the lists, and we can access them via these two variables. Order is important. It will stop if any of the lists end. As we can see, this is very useful. We can use both enumerate and zip. These braces around them are important. We will discuss more about them when we explore tuples. Let's modify our chart program to use zip. Now, we don't need to deal with the pesky indexes. Slicing is more powerful in the case of lists. Let's take a simple list of integers starting from 0. Here, the values are the same as indexes, so it will be easier to understand. We can use slicing to modify multiple elements at once. As ID remains the same, we know that it's not creating a new list, instead modifying the original one. We can change it to any other iterable, but it will throw an error if the value is not iterable. It's okay to give less number of items. It will first remove and then insert. We can also insert elements without removing, or even extend the list, which will be different than modifying a single element. Let's change every alternate element to 0. As we are modifying 5 elements, we need an iterable of 5 elements. We can assign elements from right to left using negative steps. As we can see, it is much easier to manipulate lists in Python than any popular languages like Java and C++. Try to practice all this yourself to understand it better. There are some string methods that either take or return list. One of such method is split. By default, it will split the string using whitespace characters, and it will ignore any white spaces in the beginning or the end. We can also specify a separator or put a limit on the number of splits. There are 2 splits and the remaining string will be appended. By default, split will do the splitting from left to right. We can use rsplit to do splitting from right to left. If we have a list of strings, then we can join them using the join method. Remember, all these methods are string methods, not list method. Let's try to write a program that will split the email address. Split will return list of 2 elements, and we can use the unpacking to assign them to 2 different variables. Then we will get the first string from the dot splitted list. If we are not using a variable, then we don't need to bother with a good name. We can just use an underscore. Let's write a program to create a list of squares of all the numbers from 1 to 10. Python provides an elegant way to create a new list by using list comprehensions. This is a generator expression for generating elements using a for loop. Left-hand side is the expression that we want to evaluate for every element of some iterable object. We can use if to filter out some values. Now, this will only take the odd numbers. Beware, if we put the if in the beginning, then it will take that as a part of the expression that we want to evaluate for every element. This will square only those numbers which are less than 5. We can use both as well. This will only take all the odd numbers and then square only those numbers which are less than 5. We can apply it on two iterable elements as well. Using the zip function. We can use nested list comprehension to generate a list of lists. First, it will try to create a list for each clause. Then it will evaluate this expression, which turns out to be returning another list. If we want to generate a single list instead of a nested one, then we can just remove the inner braces. This will evaluate the expression for every combination of colors and cloths, just like the cross product of sets or cross join in SQL. List comprehensions are very useful while taking the input. If we have multiple values in a single line, then we can use list comprehension to convert them to int values. We can also use list unpacking to assign them directly to a variable. Let's take a n by n matrix from the user using the nested list comprehension. First, it will try to create a list with n elements in it. Then, to get those elements, it needs to evaluate this expression, which will create a new list by taking the input and splitting it by white spaces, and then converting every element to int. We can actually do all that in a single line. Let's go back to our chart example and improve the user experience. Previously, we used two different lists for subject and marks. That approach is the basis of data-oriented design. Now we are using a single list where related values stays together in another list. This approach is the basis of object-oriented design. We will explore more on this in the later videos. As an exercise, try to further reduce this code by using list comprehension instead of using the append method. If you find this not challenging enough, then try to draw the chart vertically instead of horizontal. This can be done using only what we have learned so far. Links to the source code for the examples and assignments are in the description. Feel free to drop suggestions or questions in the comments. Thanks for watching. See you in the next video.